Example 12.7 says let G be a mapping given by g of x equals 5x plus 2x squared minus 3, and the domain of this function is going to be all real numbers. Part A wants us to state the relative extrema of G. So when I think relative extrema, I think of two possibilities. There's either going to be a relative maximum or there's going to be a relative minimum. And when we're talking about a quadratic function, we know there's only one of two that can take place. There is either a relative max or a relative min. We cannot have both. So I need to decide which one of the two I'm going to have. Be very careful when you start looking at your equation. It says 5x plus 2x squared minus 3. It would probably be helpful if you rewrote it so it said g of x equals 2x squared plus 5x minus 3. So that way it's in the ax squared plus bx plus c format, and then you can see a little more clearly that a is equal to 2, b is equal to 5, and c is equal to negative 3. Now if you can see that without rewriting it, that's fine. I've just always been in a habit of writing my equation in what we call descending order. So you have the largest power of the variable first, then the next, and then the constant goes at the end. It's called descending order. So because the a value is positive, that tells me that my parabola is going to open up. And if I know that it opens up, then my vertex has to represent a relative minimum. So there is going to be no relative maximum here, and I just need to calculate where the relative minimum is. We have two options. We can either do complete the square to turn it into vertex form, or we can calculate the vertex directly using theorem 12.2. I'm going to choose to go ahead and use theorem 12.2 since we just talked about it. Let's look at calculating h. h is going to be equal to negative b over 2a. So that'll be negative 5 over 2 times 2, which we will call negative 5/4. So I know negative 5/4 will be the x value for the ordered pair that is going to create my relative minimum. Now we need to calculate the value of k. K is going to be the y value. So all I have to do is take this x value, which we're calling negative 5/4, and I just substitute it in to the function. And this is not f, this function is g, so this should be g of negative 5/4. So this will say 2 times negative 5/4 squared plus 5 times negative 5/4 minus 3. So I'm going to go through the calculation here. K is going to be equal to 2. I'm going to start with the first term, and I'm going to start with the exponent of the first term. If I square the fraction, I'll square the top and square the bottom, and I get 25/16. On the second term, I have a whole number of 5 multiplied by the fraction negative 5/4. I'll just think of that whole number as being 5 over 1, and then we multiply the top together and we multiply the bottom together, and you get negative 25/4. And the constant is already nice, it's just minus 3. So that's good there. Continuing with the first term, I still need to multiply 2 with 25/16. That's going to end up being 25/8, and I'll have minus 25/4 minus 3. So that takes care of the substituting in of the negative 5/4 into the g of x equation, but now I would want to combine these terms together and make sure that it's just one single value. So in order to do that, I would need a common denominator. The common denominator will be 8. So 25/4 is equivalent to 50/8, and 3 is equivalent to 24/8. And then I'll add all these together, or subtract them, whatever the operation says, and I will end up with -49/8. So -49/8 represents the y value that goes with -5/4, and ultimately that is the hk, that is the vertex for this function, which we know represents the relative minimum. That's part A. Part B is write an equation for the axis of symmetry of the graph of G. So we've talked about how the axis of symmetry always has to cross through the vertex. So when it crosses through the vertex, it's going to be crossing through that point h comma k, and the equation for that vertical line is going to all have the exact same x values. So it's always going to have h for their x value. So we can just get away with using x equals h as the equation for the axis of symmetry. So specifically for this equation, we would say axis of symmetry is x equals -5/4.